you do have at least probably a broad understanding of polygon. You've heard the word before, what a polygon is. But as far as a definition that we can use and then say this is a polygon and this isn't, it's a closed, pen back on, closed geometric figure. Which is a pretty fancy word, but more specifically, it has straight sides. So weirdly enough, that means a circle is not actually a polygon because it's got the curved sides on it. So we're not doing circle math today. We're doing things that have straight sides. So the two kinds that we're going to talk about are the convex and concave. The convex ones all point out. And so pointing out is something like a simple triangle, which we've seen before. Lots of math there. Or like a weird parallelogram like this. Or everyone's favorite. Remember what this one is called. What is that last one I drew? Hexagon. Everyone's favorite hexagon. So these are convex ones that all point out. That's what convex means, is out. So that's our normal ones that you would expect. There are also concave ones that we won't do a lot of math with. But to show you what they are, they all have this interior point, kind of like this. Or maybe like this. And specifically, it's this interior point right here. Now, we're assuming that these are all straight sides and my bad drawing doesn't count as much as they're a little wiggly with my bad drawing. They are perfectly straight. But only going to work with the convex ones. So all of this will be this. All the math will be on this style. We won't be doing any math on this style. I was pointing out that they exist because they perfectly exist. But if it's the other way around, we won't be doing math on them. So we're going to start with one of the first formulas I get to give you. And that's the sum of all the interior angles in an n-sided polygon. Is just kind of a crazy sentence. But it works out to be pretty good. So it's big S is equal to n minus 2 times 180 degrees. And this little n here means number of sides. That's it. So that's what n means, is number of sides. What we do know is n has to be bigger than 2. And why is that? Why would n have to be bigger than 2? Yes, Trenton?
Because if it's smaller than 2 and you minus it, then it's going to be like...
Well, it'll get a 0 in there, and that's bad. But what else do I know about n2? What does n mean in this case?
Number of sides.
Yeah. Okay, few examples to get you guys used to this. A 5-sided shape. I can just do the math on this one. S is equal to 5 minus 2 times 180, which will be 540 degrees. So all the angles inside of a 5-sided shape add up to 540 degrees. Now I'm going to draw this one. I'm not going to draw the next one. If I just draw a nice, simple 5-sided shape, doesn't even have to be like even, it just has to have 5 sides. If I add up this angle plus this angle plus that angle plus this angle plus this angle, all those angles add up to the 540. So it's each of those angles all added up. Some of them can be the same, some of them can be different. It doesn't matter what each of them are. All 5 of them have to add up to 540. And so that's our first fact of this lesson. Now, that's the last one I'm going to draw because there's no way I'm going to be able to draw an 18-sided shape, but we can still do the math on the 18-sided shape. That's the sum of all the interior angles is equal to 18 minus 2 times 180 degrees. Now, that's very, very much a calculator question because I don't know what 16 times 180 is. That's not something I keep in my brain. But the calculator tells me that's 2880. So it's 2,880 degrees altogether, which is a lot. It's a lot of angles in there. An 18-sided shape is, if you're drawing it small enough, pretty close to a circle. Speaking of weird-sided shapes, like a lot of money is actually flat-sided, even though they're basically circles. A loonie is flat-sided. It's actually only got 11 sides. So a loonie has 11 sides on it. It's kind of weird. Q sides, it's just a spacer. Basically, we can do S equals Q minus 2 over times 180. And we can do math on this, but I don't really need to. You can do the rearrangements. I know Math 10 taught you how to do the rearrangements of this. It's not terribly useful. That's good. A few special labels, and they kind of speak for themselves as far as what these words mean. An equiangular polygon, all the angles are the same. So, all of the angles are the same. An example of this would be a rectangle. Like a nice long rectangle. Right? All 90 degrees in a rectangle. Right? I got a 90 degrees here, 90 degrees there, 90 degrees there, 90 degrees there. So those are my equiangular. Let me slide up so you guys can all see. Equiangular one. An equilateral polygon, all the sides are the same. So my favorite example of this one is the rhombus. So that's this lengths are all the same. That is a rhombus. Or a rectangle. Now, the term regular, just like the straight up term regular in geometry, means both sides and angles the same. Both sides and angles are the same. So both all the sides and all the angles are the same. My favorite example of this is a square. All the sides are the same and all the angles are the same. Hopefully your square looks slightly better than mine, because my square looks a little sad. Okay, so we're going to look for how big each angle inside of a regular polygon is. So I'm going to use the letter I to say interior angle, and it's going to be n minus 2 times 180 divided by n. I'm going to just write this in here in case you weren't listening. Interior angle. So I'm going to draw something boring. Let's just do the hexagon here. Now I'm going to try to draw this regular as best I can. Okay, so if I say this is a regular hexagon, that means all the sides are the same and therefore all the angles are the same, regardless of however bad this particular drawing happens to be. And the interior angle is basically one of those. So how big is that angle in there is what this particular formula will tell us. And remember, n has to be bigger than 2. That's also has to be true because you can't have a shape with less than 2 sides. So this is our second formula. Our interior angles are here. That's that I right there, one interior angle. So if I want to know how big this angle is, I can use that formula. My examples are going to be in our next little bit here. So we're going to do the example of an 8-sided shape. So for an 8-sided shape, we're going to use the formula I is equal to 8 minus 2 times 80 degrees over 8. And we're just going to get that out of our calculator. So we're just going to go 6 times 180 divided by 8. And put that in my calculator just to make sure, test myself. 6 times 180 divided by 8. 135 degrees. So in an octagon, an 8-sided shape, each interior angle between these two sides would be 135. This is a hexagon, so it's a little different. But in an octagon, it's 135 degrees. Fantastic. Would we expect the 16-sided shape to have a bigger angle or a smaller angle?
Bigger.
Much bigger. Well, not much bigger, but definitely a little bit bigger. They're wider and wider and wider. So let's do the math on this one. I is equal to 16 minus 2 times 180 degrees, all divided by 16. And let's see what I get out of that one. It's going to be a little bigger. 14 times 180 over 16. I get 157.5 degrees. So it's getting wider and wider and wider. What's the biggest you think you can get for an interior angle? What do you think the biggest might be?
1,000.
No, it can't get 1,000. That's way too big.
200.
Nope, can't get 200. That would be impossible.
What?
1. I want the biggest angle,
180.
180, right? From this right here. It can't be bigger than 180 because that would be all the way flat. You can't be more than flat because then it wouldn't be the right kind of shape. So you can't get to 180, you can get to just under 180. That would be an infinite-sided shape, circle. So that's where we're at here. Oh, we can do the math on this one. This one's going to be fun. This is where you guys are actually going to probably struggle. Everything so far has been pretty easy. This is one where you're going to have to use your algebra skills. So a regular polygon has 162 degrees inside of it. And then we have to figure out how many sides does it have. So let's put all the numbers in that we know. We know that it's 162 degrees. And so we want to go n minus 2 times 180 divided by n. And so I want to be super clever and solve for the n. Isn't that fun? But there's 2 n's. How do I math this?
They're the same.
They are the same n. So whatever number they will be, it will be the same number. So we use our math skills to try to put them all together. So those of you that remember your 9th grade solving equations math, how do we do this? What step do I do mathematically to try to solve for n? I'm going to try to get rid of this bottom n. So I'm going to multiply both sides of this equation by n. So I'm going to multiply an n over here, and I'm going to multiply an n over here. Over on this right side, these 2 n's will be equivalent. They can cancel out, is what we say. And so the next line of math will look like 162n equals... Oh, I'm also going to do this part. Ha! I'm going to take this n and times it by 180. I'm going to take this 2 and multiply it by 180. It's called the distribution step. It's very fancy. Some people have called it rainbows because it like arcs over, kind of like a rainbow. You use this all the time when you were doing like FOIL and all that other junk that you did last year that you totally remember. Next thing, we're going to get 100 and, whoops, it's not one, undo here. 180 n's minus 360? Yeah. Undo 360. The 360 here comes from 2 times 180. That's that step there. Ooh. Now we've got this one. We still have 2 n's. What shall I do next? Yeah, which math? I want to do one of the operations. Add, subtract, multiply, or divide. Yeah, cancel isn't actually a math word. We use it as a shorthand for doing multiply, divide, add, or subtract. We're actually going to do a subtraction step next. It was a little bit of a guess, but we're going to subtract both sides by 180. Remember, when we're doing solving steps, it always has to be the same on both sides. If it's not the same on both sides, that's breaking the rules of math. So, what happens when I take 180 and I subtract 180 from it? What do I get? What's 180 minus 180?
0.
Nothing. So that part goes away and I'm left with minus 360. So I have to write minus 360 on this side. What do I get on the other side? What is 162 minus 180? Huh?
Negative.
Yeah, it's negative something.
2.
That's 18. Use the calculators, guys. It's not, you don't get extra points for doing it in your head. Use your calculators. It's fine. So let me slide that up. You guys probably can't see it. It's way back there. So that's what we're doing here. So we do this. And now what should I do next? I want to get the 18 away from the n term.
Plus 18.
I don't want to add in this case. What I'm going to do is the opposite of what's between them two. What's between 18 and n?
Times.
It's a times between the two. So any of the numbers stuck to a letter, that's a times. Like it's supposed to be 18 times n, but we're going to do divide. So next step is divide. Next step is divide. Now we can do this math in our calculator. What is 360 divided by 18? It is 20. Well, we got to use, they're both negative, so it's actually going to be positive 20. And that's good, right? Negative 20 would be really weird, right? What would negative 20 for n mean? That means the shape would have negative 20 sides, which is weird, right? So it having a positive number 20 makes good sense. So it's 20 sides is this shape. So that's the crazy algebra steps. Do you guys feel, I know you guys aren't the most talkative group when we're doing this algebra steps. Do those feel like at least kind of familiar or not? And I really can't draw a hexagon that well. But exterior angles are these little extensions that I'm going to measure. Oh, that was bad. Just basically extend each of these lines a little bit. Like that, and then like that. So each of the exterior angles are these little gaps in here. That's an exterior angle there. So each of these little gaps here are called exterior angles. So that's our weird definition there. So exterior angles are all there. So each one is going to be E is equal to 360 over n. So we just take 360 and divide it by how many sides? So for this particular example, E is equal to 360 divided by the 6 sides that this hexagon has. What is 360 divided by 6? Well, it's 60. So I know each of these has to be 60 degrees. So each of those little things. And they look roughly 60 degrees. So my drawing's not awful. They're roughly 60 degrees. That looks okay. So that's different. Okay, that's that. Okay, so each exterior angle is 12. So our formula, remember, was E equals 360 over N. So we just need to solve this for N. So let me write down the numbers that we have here. We know E is going to be 12. And this number is 360. And this number is N. What do I do with my algebra steps? You following kind of the stuff I did before. What's what I should do first? What math step can I do first? I got to move N first. So I'm going to multiply by N. So I get 12N equals 360. Next step is divide 12. Divide 12. So I get N is equal to 360 divided by 12, which is going to be 30? Yeah. So we get 30 sides in this case. N is equal to 30 sides. The next thing I'm going to do is interior angles. It's super fun. So an interior angle is 5 times the adjacent exterior angle. This is fun. So the fact that I'm going to work with here is that adjacent means basically right beside. So if I draw just any angle here, we're going to do this one is the interior and this is one is the exterior. Right? Because the exterior lines are measured on like this extension of the other ones. And so basically what we have to do is like, I have this straight line here. So what do I know that I plus E equals? What does I, the angle I, in this case, what is the angle plus the angle E? What do they have to equal? It has to equal 180 because of the straight line. So the straight line right to each other, they have to equal 180. So the question here is like the interior angle is 5 times the exterior. So I'm going to replace this I with 5 times E. So I get this fun thing. I get 5 times E plus E equals 180. How many E's do I have now? Not all at once. 6 E's. Now there's 6 of the E angle, and they add up to 180. Oops.
Why is this guy cruising?
What's next? What's my last step to find out what E has to be? What do I have to do to this equation? We're going to use division. Do 6 on both sides. 180 divided by 6 is 30? Cool. What does N have to be? How many sides is that? Mm, 12. All right. Last one. Let's see if we can remember all of our fancy names for all of these things. 3-sided shape.
A triangle.
Very good. 4-sided shape. Yes. In this case, That's the one. Quadrilateral. Using up the whole blank for that one. Okay, it's going to get easier now. What's 5? Pentagon. 6, I've used so many times. Hexagon. Anyone know 7?
Septagon.
It's not that one. It's very close, but it's not that one.
Pentagon.
It's heptagon. I think we know 8.
Octagon.
Octagon. Nine? That's, yeah, that was most of it. Nonagon.
Actually,
It is nonagon. 10.
diagon.
Almost, no. Decagon is right. Now this one's going to be a little tricky. Does anyone know 11?
11agon.
No, it's not an 11agon, which is would be easier. It's not terribly exciting. It is an undecagon. Is right. That's it. I don't want to go past those. They do exist. Names for those exist, but 12 is plenty. And N is very boringly. They just call it N-gon. So if it's a blank shape, they'll call it an N-gon, especially in a problem where I'm asking you to find out what side it is. This gon means it's a polygon, so I know what else is going to happen in it. Did I write down what you should do now? I didn't. Hey, go ahead. Let's write down what it is. It's page 73. And it's 1 through 4, 5, A through F, 6, 8, 9, 13.